In Lesson 5.1, we're going to be learning about using integers as exponents. And so our targets in this lesson are 1. To be able to simplify numerical expressions that have integer exponents. 2. To be able to simplify algebraic expressions that have integer exponents. 3. To multiply and divide algebraic expressions that have integers as exponents. And 4, to simplify sums and differences of expressions that involve integer exponents. Now on my slides posted on Canvas, you can see on slides 3 through 8, I believe it is, an explanation of why these properties that we're going to learn about here today for exponents apply and are true in all situations. So I'm going to let you peruse those slides on your own, and I'm going to jump ahead to slide number 9. On slide number 9, I begin to summarize the different properties that we've learned for integer exponents. And so these properties are going to apply even when our exponents are negative integers rather than positive integers. And I see that the formatting didn't come through here correctly, so let me make some adjustments. So the first property highlighted here is the one that tells us that when we're multiplying two things together that have like bases, like b, and they're being multiplied, then we add their exponents. So b to the n times b to the m is equal to b to the n plus m. The second property reinforces the multiplication property, that if you have one base but it has an exponent inside the parentheses and another exponent outside the parentheses, that's when you multiply exponents. The third property displayed here is the one that I like to refer to as the distributive property for exponents with multiplication. And that just means that if you've got a product inside the parentheses with an exponent outside, you basically distribute that exponent to everything inside the parentheses. The fourth property here I like to refer to as the distributive property for exponents with division. So if you have a quantity inside the parentheses that involves division and an exponent outside the parentheses, once again you basically distribute that exponent to everything inside. And then the final property that I have here is property 5, that says that if you're dividing two things that have the same base, like b, then what you do is keep that base the same but subtract their exponents. So what we're going to do is we're going to apply these properties that we have learned previously now to integer exponents, but we're going to focus a lot on those that have negative integer exponents and those that have an exponent equal to 0. So I'm going to work through a number of examples here with you. So this is example 1A, which can be found on slide 11 for lesson 5.1 in Canvas. And it just says, what's 10 to the negative 3, times 10 to the positive 2? Well, this is a situation where we're applying property 1, which says that when you're multiplying like bases, you add their exponents. So I'm going to add negative 3 and 2. And I'll get 10 to the negative 1 power. Now, typically you're going to find that they're going to ask you to express your answers with positive exponents only. So there's another property for exponents that says that anytime you have b to the negative power, that is the same as taking the reciprocal of b and raising it to a positive power. So basically a negative exponent just tells you to flip the base. And when you flip the base, the exponent becomes positive. So 10 to the negative 1 is the same as flipping 10, which is 1 over 10, and now it will be to the positive 1 power, which of course is equal to 1/10. So example B here says to raise 2 to the negative third power and then raise that to the negative 2 power. So this emphasizes property 2 that says this is when we multiply our exponents. So negative 3 times negative 2 is positive 6. So we get 2 to the positive 6, which basically means multiply 2 by itself 6 different times. And that ends up being equal to 64. Example 1C, you notice inside the parentheses we have things that are being multiplied but their bases are not the same. So we cannot add their exponents. So what we rather need to do is to distribute the exponent outside to each of the exponents inside. And of course this is the property that tells us to multiply. So for the base of 2, the exponent of negative 1 inside gets multiplied by the exponent of negative 1 outside. Negative 1 times negative 1 is positive 1. For the base of 3, 2 inside gets multiplied by negative 1 outside, so we get 3 to the negative 2. But that again is not considered a simplified answer because you have a negative exponent. So once again, all you do is you leave the base that has a positive exponent alone. You do nothing with it. But this 3 to the negative 2 will become 3 to the positive 2 when you move it to the bottom, which is like writing it in its reciprocal form. That's like 1/3 to the positive 2 power. So now you've eliminated the negative exponent. You have 2 to the 1 on top, which is 2, over 3 to the 2 on bottom, which is 9. So it simplifies to 2/9. In part D of example 1, you can see we're going to need to apply the distributive property for division. Once again, we're dividing things that do not have the same base, so we cannot subtract their exponents. So what we need to do is, again, distribute that exponent to each quantity on top and bottom of that fraction. And this, of course, is when we multiply those exponents. So on top, the exponent of negative 3 inside times the exponent of negative 1 outside is equal to positive 3. And on bottom, the exponent of negative 2 is multiplied by the exponent of negative 1, and negative 2 times negative 1 is positive 2. So this is nice because we have no negative exponents. So we just cube the 2. 2 times 2 times 2 is 8. And we just square the 3. 3 times 3 is 9. So our simplified answer is 8/9. And finally, for example 1, part E, now we are dividing things that have the same base, so we can subtract their exponents and apply them to that base. So the negative 2 exponent on top, I need to subtract from it the negative exponent on bottom. So I'm subtracting a negative 4. That is the same as adding positive 4. A double negative becomes a positive. So I basically get 10 to the positive 2 power because negative 2 plus 4 is positive 2. And 10 to the second power is the same as 10 times 10, which is equal to 100. So that provides you with a few examples, simplified examples, that involve using these properties that we've learned about for exponents, but applying them to situations where we could possibly have negative exponents. My next video will continue on with example 2, which begins on slide 15 of the lesson 5.1 PowerPoint on Canvas.